All right, hello everyone. Hi. Welcome. Let's go ahead and get started. Hope everyone had a great weekend. Some announcements, some reminders before we head into today's material. I'm sure you're all probably wondering about the exam that you took last week. The grading has been in progress. I think that it's possible you'll get your grades back tomorrow. I think Wednesday is probably a little bit more likely in terms of how much longer it'll take us to finish up. There will be a way to submit regrades, so there's over 450 people took this exam. I'm sure we screwed up somewhere. That is absolutely a fact. So there definitely is a way to submit regrades. All that information will be posted once the exam grades come out later this week. And you'll be able to submit regrade requests once that happens. There's no homework assignment due this week because we had the exam last week, so that's kind of nice. We do have a studio this week. And then next week, we actually have fall break. So 1 week from today, no class because we'll be on fall break. And then there actually still is a studio next week, but because of fall break and stuff, your next assignment isn't actually due until the 16th or the 17th, depending on what your lab section is. So this class, we kind of have a nice little break for a little bit. We're going to keep moving, but yeah, not a whole lot going on at the particular moment. So look to see the exam grades coming back in the next couple days. Otherwise, kind of chill for the next couple weeks in this class, and you have some time to hopefully enjoy your fall break, take some time off. Any questions about logistics or the schedule or anything like that before we hop into do some coding exercises? Okay. Awesome. Great. So today is a fun topic, I think. The official topic for today is called APIs, which stands for Application Programming Interface. And that's a very big fancy word for basically reference material. So it's how do we look stuff up? How do we understand what is available to us so that we can use those tools in our programs? The idea here is that lots of people write code. Instead of having to redo the code that's somebody else has already done, I would like to be able to use their version of it, right? And so what people do is they put their code online, or they make it publicly available in some other way so that you and I and anybody else who's interested can use that code. But they need to provide instructions on how it works. Otherwise, we're not going to be able to use it effectively. So that's what's known as an application programming interface. It's basically a list of all the ways that you can interact with a particular piece of code. And the nice thing about it is that we don't necessarily need to understand how the code itself works. We just need to understand that if I plug in value A, it's going to give me value B back. And how does it do that? I don't know. That's computer magic, right? But we just trust that if it tells me I plug in A and it gives me back B, then that's what it's going to do. You've actually already been using an API. You've already been using tools that have been written by other people and not yourself. The classic example of that is actually the scanner class. So I wanted to start by pulling up the scanner API. We've been using scanner basically since the first day of class, right? Scanner is what we use to read in values from the keyboard. So if I want to ask the person sitting at the computer to type something in, scanner is the way to make that done. And we've seen lots of ways that we can interact with scanner. But there's more. There's more ways that we haven't yet seen. And so if you want to find the API, the reference material for scanner, I'm usually going to type, scanner Java or some such into Google. And I'm looking for the page that says Oracle on it because Oracle is the company that owns Java. So they are the ones that publish all of the official Java documentation. Can you look at these other websites? Absolutely. They're also probably great references. Probably going to have a lot of the same material that's on the Oracle one. But this is the official one. And so this is the one that I typically am going to look for. Java APIs are almost always going to look kind of similar to this. They include a description up at the top with an explanation of what this is for, and they oftentimes include little code snippets that you're welcome to just go ahead and plop right into your code and use. That's great. So, we don't need to go through all this stuff. There's actually some stuff in here that I haven't used a whole lot. I haven't thought about a whole lot, and that's kind of okay. The idea behind an API is that it's going to list everything that that the scanner can do, and we just need to cherry pick the parts that we want to use for our program. So what is our goal? What do we want our code to do? look for those kinds of functionality within the API, and then you just have to use those parts. So really, one of the most important things to look at is what's called the method summary. These are all of the actions that Scanner can do for us. And this is also kind of a nice little sneak preview of what we're going to be talking about, not next week, because we're on fall break next week, but the week after that, Module 5, the one right after this, is actually called Methods. So we're going to be talking about methods a whole lot coming up in the very near future. But for now, let's take a look at what's already provided here. You can see there's a lot of them. If I keep scrolling down, though, there's some that you already know about. You've probably seen this one before, and this one before, right? Next int, next double, next line. And each one has a description along with it that describes what it's going to do. So we already know kind of what these are. You might be looking at this and saying, well, that's not really how I would describe what nextInt does, right? That's a very kind of Java technical sounding way of doing it. But it's basically doing exactly what it says. It's going to look at the next token or the next chunk of the input and find an integer. It's going to look for an integer value, right? So you can see all these next ones are available to us. As well as many other methods. I got to be honest with you, I've used a good portion of these. I've not used them all. I know how some of these methods work. I don't know how all of them work. I don't need to know how all of them work. That's not really the point. Memorizing, all of this stuff would be a waste of time. I need my brain to do other things. I need my memory for other stuff, right? So APIs are great because all of this information is available to us. We don't need to memorize this stuff. We just need to be able to look it up and read about it and understand it and then use it, apply it in our own code. So as an example of how we can do that, we're going to actually use Scanner to do something that we haven't done before yet. You're actually going to see this coming up, probably not on this week's assignment, but on the next assignment, assignment 5. You'll see this being used a lot more. But so far, we've only been using Scanner to read in stuff from the keyboard, right? So somebody has to actually type something in. It can also be used to read in stuff from files. So that's another very handy thing that Scanner can do for us. If we don't want to type data in, but we actually have a file with a whole bunch of data in it, we can use Scanner to do that as well. And this is, the code that's used to set this up. You can actually see this comment right here. This is code for setting up Scanner with the file. Not your responsibility to understand this part. This isn't really the goal of what I'm trying to show you today, although I don't think this code is terribly tricky to understand. It creates a little file chooser. You've almost definitely seen one of those before, where it just lets you pick a file, and then it creates a file and passes it into the Scanner. The real interesting stuff is down here. The Scanner is called in, and so I can use any of the methods that I find here as part of this file. And so if I scroll down, one of the things that you'll see, there's two big categories. One of them is called, next double, next int. That says, give me the next chunk of input that matches this type, right? And then there's another big chunk up here called has next. This is asking the question, is there an integer in the file for me to read? The answer to that is going to be either yes or no, true or false, right? So you can see it tells me right here that a Boolean value is going to be given back to me. So I'm gonna ask the Scanner, hey, do you have another integer in there? And it's either going to say true, yes I do, or it's going to say false, no I don't. If it says true, I do have another int, then that means I know for a fact it's safe for me to go ahead and say, give me that next int. So that's the difference between has nextInt and just nextInt by itself. One is asking the question, are there any integers coming up? The other one is saying, give me the next integer that you find. This can be useful because in a file, if you ask for something that's not there, then it's going to crash. It's going to crash the program. So one important thing to do with files is kind of understand the format of the data that's going to be coming to you in the file, and also make sure you're reading it in appropriately. So as an example of that, this code is somewhat new. We're using has next double along with next double. And we have some data files that we can use as well. This one called data is very short. It's only got 5 values in it. But this one, as its name implies, has 1,000 values in it. So much more stuff for us to play around with. They're all doubles. And if I go ahead and run this program for you, you can kind of see what it's going to do for me. If I pick 1K doubles as my file, it's going to read in each value and print it out. And actually, if you want to see this in a little bit more detail, we can set a breakpoint here on line 30 and run it through the debugger just to see exactly what's happening. So line 30 is saying, are there more double values to be read from the scanner out of the file? If the answer is yes, it's going to go into this loop, right? And then it's going to say, all right, now give me the next double in the file and print it out. So there's the very first double that it found, 9.04. If we go all the way back to the top, right? Let's see, 9.04. Okay, and so it's just going to keep doing that. Obviously, I'm not going to go through this in the debugger 1,000 times, right? But that's what's happening. A couple things to notice. Can't go backwards, right? I grab that first number out of the file, I do whatever I want to do with it, and then it's gone. There is no way for me to then go back and say, hey, give me that last number again. That's not possible. If you want to be able to reference that number later, what might you be inclined to do? Yeah. Store it in a variable, or if I'm reading in a lot of values, like in this case 1,000 of them, I might want to stick it into an array, right? Stick it into an array. In fact, that's exactly what you're going to be doing on assignment 5 next week. You'll be doing very similar to this, reading these values in and storing them into an array. This particular example doesn't want us to do that. They want us to find the maximum, the minimum, and the average, and some other values. I'm not going to do all of those aggregates, but I'll do one of them, and then you can kind of use that idea to help you figure out the other ones. Let's go ahead and find the maximum value out of here. Okay? So the first thing that I need to do is probably have a variable to store my maximum. So I'll go ahead and make a double called max. What should this start at? 0. What if there's, what if all the values in the file are negative? That's no good, right? If every single value in the file is negative, then this is going to tell me that 0 is the maximum. But wait a second, everything's negative, so I can't make that be 0. Yes? I love that idea. So equal to in.nextDouble. What is this going to do? This is going to, oops, if I spell it properly, it's going to read in the first value from the file and say, you're my maximum value. Is that true for, all the values in the file? No, but if we find one that's bigger later on, we can just replace it, right? So I'm going to assume that the maximum value is just the first one, just the first value that I see. You're my maximum. I haven't seen anything else yet, so you're the largest thing I've seen so far, right? I haven't seen anything else. Now we're going to go through, and we're going to say, hey, while there's more numbers, if in.nextDouble is greater than my max, I have a new maximum, right? I have a new maximum value. If the value I'm reading in next is bigger than the current maximum, then I have a new maximum. So we'll set our maximum to be in.nextDouble. Oops, we'll terminate that. Yeah. Okay. And so let's go ahead and run this and see what happens, right? I'll pick my 1K doubles. Oh, I never told it to print the maximum. That's my bad. I need to tell it to print out the maximum when it's done. So after the loop is over, I'm going to add this print statement down here so we can see what the maximum value in the file is. Now I can run it. All right, it's telling me the maximum value in the file is 88,589. This actually, it might be the maximum value in the file, but I actually suspect that maybe it's not. Anybody know why I'm a little dubious of this? Anybody see a mistake I made? Or other potential problem? Yeah. Yeah. It's not quite it yet. I have to do what? I mean, it's called 1K doubles, and I think that's true. Also, an integer can be a double, like 7.0. That's a perfectly good double. Yeah. Nope. Still not there. It's a tricky one. Yeah. Bingo, bingo. We're using in.next double twice here. Remember, when I say this, I'm saying give me the next number from the file. So we pick the first one out. It says that's my maximum. It says, all right, if the second number in the file is greater than the first number in the file, then give me the third number in the file, right? And that is my maximum. Did you see? Did you follow along with me? So using in.next double twice here is not the right thing to do. The suggestion was to make a variable for that. I love that idea. So if I make a double, just a temp variable, or call it next value or something like that, a little bit more accurate, we'll store that into our temp variable and then just use that instead. And now, hopefully, we'll see if this answer changes or not once I do this. Oh yeah, it did change. Look, that is in fact a bigger number than 88,000, right? Yes?
Would it be any worse to just save this, use the next double to save it into an array so we can reverse it how we want in order to
It depends on what you want to do. So the question is, should we just stash all this stuff in the array so we can do whatever the heck we want with it? I mean, it depends on what you want to do. If all you're trying to do, in this particular example, all we're trying to do is find the maximum, minimum, so on and so forth, I don't need an array for that. I can do that as I read the numbers out of the file. I can compute all of those on the spot as I read them out. There's no need for me to do that. If I suspect that I might need to use those numbers again later on in the future, then yes, I think putting them in an array is a wise idea, right? But here, we can do it all in one pass. I don't need to make a second, third, fourth pass to pull this off. So an array, while not technically wrong, just kind of overcomplicates it a bit. Yeah, great question, though. Any other questions about this particular example? Yes?
What did you say that how this code works? If the second number in the file is greater than the third number, then give me the third number?
What I had before said, if the second number in the file is bigger than whatever the maximum is, then give me the one after that. So it was actually checking every other value in the file, if that makes sense, and then storing the wrong one if it found a new maximum. So the new version that I have up here, oops, I went the wrong direction. The new version says, all right, read in the first value. Now read in the second value, but it's as a variable. So this is still the second value, this is still the second value. And then not until the next time I go through the loop is this going to be the third value in the file, third value, then fourth value, right? So every time through the loop, instead of reading in two numbers, that's what I was doing before, now I'm just reading in one number every trip through the loop. Yeah. Awesome. So finding the minimum and the average and all of this stuff that it's asking for would follow a very similar format to finding the maximum. I'm going to leave that all up to you to kind of figure out on your own. I want to show you another API that we're going to use. It's a really, really fun one. This is a very interesting and fun to use API. We're going to start dealing with graphics and drawing stuff on the screen. So let's take a look at some of these graphics things. The graphics, so there's more than one way to draw things on the computer, right? We're using an API that is called Standard Draw. It's a very common one, specifically intended for introductory computer science courses. It's made by Princeton University, their computer science department. They have a textbook that also kind of goes along with this material, although I haven't, that was a long time ago that textbook existed. I'm not sure if they still are updating that or not, but this is the Standard Draw API, and it, right off the bat, it shows me a whole bunch of different things that you can do with it. And if you keep scrolling, it'll have instructions about, the various commands that are available to you, including colors. And I'm not going to have time to go through all of these today, right? But I'm going to try and show you some of the important ones, give you kind of an overview. And then the idea is that if you ever want to make a drawing later, you can go look at these yourself and say, oh, okay, I want to do this. Here's the method. Here's the procedure that's available for me to interact with the things that way. So yeah, let's start by taking a look at a very simple example that uses graphics. First, let's talk about colors. There's two ways we can do colors. So there are some built-in colors, the ones that you might expect, green and blue and whatnot. Oops. You can also make your own color. So here's an example of using a custom color. There are 3 values associated with every color that gets made on your computer screen. This says how much red there's going to be in this color. It's a value from 0, which means no red, to 255, which means as much red as possible, right? This is the green value, same thing. 0 means no green, 255 means all the green. And then this is a blue value. So RGB, red, green, blue, is how we represent colors on the computer. And by varying these numbers, these 3 numbers, you can make any color of the rainbow, right? If you want to, I mean, some of you maybe have already done this, but there's definitely a way to, pick your own colors using any of the various tools that are out here. So if I click on a color, right, it'll tell me the RGB values that I can plug in to make that color in my code. So that's kind of nice. The other thing that we can see on here is that we're drawing some shapes. So this one says filled square, and then I see some numbers. Well, what the heck do these numbers represent? You might have a guess, an educated guess, but we don't need to guess. We can use the API to tell us exactly what these numbers represent. So filled square. All right, what the heck does filled square do? Let's go to the standard draw API and do a Control F to search for filled. Oh, here we go. See, there's not just filled square, but filled circle and all these other things. Okay, filled square. I can even click on it to go down to the documentation here. It tells me double X, double Y. So that's a coordinate, right? Those first 2 values seem to represent a coordinate. And then the length, the half length, it says draws a filled square of the specified size centered at X, Y. So if I look at this, it's saying draw a filled square at 0.5, 0.5 with a width of 0.2. And if I run this code, we'll see that square pop up. I'll talk about the circle as well in just a second. Let's talk about a coordinate system for a minute. It works as you might expect, very similar to the coordinate system you learned about in algebra all those years ago. 0, 0 is down here in the bottom left corner. This is going to be 0, 1. This is going to be 1, 0, and then the upper right corner is going to be 1, 1. So if I say, 0.5, 0.5 for my center of my square, that's dead center of the whole window, right? Dead center of the whole window, because this is 1, 1, so 0.5, 0.5 is right here. 0.2 is the half width, or, it's not the technical term, I guess, for a square, but it's like the radius, right, of the square, I guess. I don't know. It's a little strange, but yeah, it's from the center out to the edge. That's the half width. So it takes care of that. So think about, all right, if I want to move that square somewhere else, maybe I want to move it down a little bit, I need to change my y value. I need to make it smaller. If I, change this y value a little bit and run the code again, we see that, oh, okay, now my square is moved down, right? Pick whatever coordinates you want. Maybe I want it to be a little bit bigger, 0.25 for the size. Let's make this square a little bit bigger, right? So just by tweaking these values, we're interacting with standard draw using the API. It's telling me, you put these numbers in, I'll put the square on the screen. How does it do that? Honestly, I don't know. If I really wanted to, maybe I could go in and figure it out. But I don't need to know how it actually changes all of these individual pixels into green, right? That's not necessary for me. I want to draw a square, I got my square. That's all I need. That makes me happy. Okay? You can see these windows are going to start piling up on us here as we go through. So then down here for our circle, this one's fun to play around with because I can, tweak the color a little bit. It says purpley, although it looks more pink to me, doesn't it? It's got a bunch of red and some blue, but no green. If I put some green in there, that should switch the color a little bit. We can play around with the colors and see. That looks even more pink to me. What if I crank it all the way up to 255, the maximum amount? Well, now it's yellow. Okay. And a little hard to see, at least on my monitor. Cool. And so I may not do every single one of these, but let's see if we can start with a couple of these, one or two of these. They want you to use the API to do the following shapes. Let's draw an unfilled red triangle somewhere. Okay. An unfilled red triangle. So your first inclination might be to come up here and say, all right, triangle. Let's search for triangle. There's squares, there's circles, there's shapes. Uh-oh. No matches for triangle. It does not say triangle anywhere in this document. Does that mean we can't draw triangles? Not necessarily. It just means that we haven't found a suitable way to do it yet. Let's look and see what else we can do. There's unfilled things, right? Filled and, well, what's going on? Does it say triangle? Why isn't it coming up with any? Oh, there we go. So there's filled things, filled rectangle, filled Python. I see circle, ellipse, square, rectangle. These are all filled. I can draw arcs. That's interesting. Oh, here we go. Polygons. Polygons. Triangles are polygons, right? Yes. Yep, absolutely. How does polygon work? Polygon takes in two arrays, an array of x values and an array of y values. These are what kind of arrays? There's a word that starts with P we've talked about. Parallel arrays, right? These are parallel arrays. One for the x values, one for the y values. If I want to draw a triangle, each of these arrays are going to have three values in them, right? One for each vertex, one for each point of my triangle. So, we can make arrays. Double. I know it showed an example, but I'm going to go ahead and make up my own numbers. We'll say 0.25, 0.75, 0.5 for my x values. Feel free to make up your own x and y values. You don't have to follow along with me. We'll say 0.25, 0.25, and 0.75 for my y values. That should make a triangle. We'll see. And then I need to say standard draw dot polygon and pass in those two arrays, x and y. Now I didn't change the color. It did want me to do it in red. So if I want to change the color, I need one of these set pen color statements. And take a look at what I'm going to do. There's, you don't have to type it all out if you don't want to. It's very, very acceptable to grab a statement that you know works in a different part of your program, copy it into a different section, and then tweak it. That's programming. Do that all the time. All right, I've told it I want it to be red. I've made these arrays to represent the points. Let's see what kind of a triangle. Hey, there it is. There's my unfilled red triangle. Are there any questions about how I got there? From where I'm at? Yes. How did I make it unfilled? Great question. So there's two versions of Polygon. This one says just Polygon, and this one says filled Polygon. I mean, it's sort of, I guess, somewhat implied that this is the unfilled version, but you can always mess around with it if you want to and type in filled Polygon, right? To see what this one will do. There's the filled version. That's the other great thing about coding and the other great thing about using APIs. Even if you read the instructions and you still aren't quite sure exactly what it's going to do, you can write a little bit of code and try it, right? Just try it out. Yes?
Why would it put the red triangle over the green square? Or do we not really need to?
Oh, good question. Why did it put the red triangle on top of the green square instead of the other way around? It has everything to do with the order that things were drawn. So since I drew the square first, right, it got drawn first and the triangle came on top of it. But if I take the code for the square and I move it after this code for the triangle and run it again, you'll see that now the square's on top. Yeah. Yes. I'm sorry, I can't hear you. I just use my good friend Google to Google Standard Draw, but also I link to the API very liberally in the prep work for today. So if you go to the Module 4 exercises, Standard Draw API is linked all over the place. Yep, but Google will get you there very quick as well. Google is definitely your friend when looking up programming stuff. All right, so that's graphics. That's a lot of fun. Standard Draw can do actually more than graphics. It can also interact with the keyboard and the mouse, but it's going to be, so we've already used the keyboard, right, for typing in stuff, but when I say using the keyboard with Standard Draw, it's actually a little bit different than that. The keyboard in this case would be more like what you would expect for maybe playing video games or something like that, as opposed to typing in, you know, your name or something based on a prompt. Although I suppose you could use it for that too if you wanted to. Let's take a look at how the keyboard works real quick with this simple example. The way that the keyboard works for these types of applications, you can see, oh, this looks pretty similar to what we talked about just a few moments ago. Has next key typed. So think about what this loop is doing. This loop is sitting here and saying, have you pushed a key? 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 It's asking that question very fast. In fact, it can ask that question so fast that we are telling it to slow down a little bit. We're saying, hey, pause a bit. This number is in milliseconds. So every 100 milliseconds, it's checking to see if I've pushed a key on the keyboard. That's what this code is doing. While I have not pushed a key on the keyboard, it's going to sit here and keep waiting for me to push a key. As soon as I push a key, this while loop is going to exit, right? As soon as I push a key, has next typed will be true, which means that this makes it false, and the while loop will exit. So now we have to ask, okay, what key was pressed? What key did they actually push on the keyboard? And we can use comparisons for that. So here I'm checking it against Y. Here I'm checking it to see if the character is N. And then otherwise I'm saying, I don't know what you typed. But the way that I can get that key is using the next key typed value. And notice the type over here. This is actually our first new data type that we've introduced since the first day of class, basically. This is used for characters. So strings are used for strings of characters, where a character is one character, right? So this is what represents one character. And if you pronounce it char as in Charizard, you are wrong. It is pronounced care as in character. That was kind of a joke. It's very subjective, and people like to fight about how you pronounce this word all the time. But I pronounce it care as in character. Is there a question over here?
Yeah. Does it have all the same properties as the data type string?
No, because it's only one. It's always going to be one and only one. Never 0, never 2. One letter every time. Strings can have 0 letters, right? Technically, and they can have 100 letters. So they are different. They are different. If you dig deep enough into a string, you'll eventually find cares, though. They're there. Also, too, notice here's another giveaway for when you're dealing with characters as opposed to strings. For single letters, we use single quotes, and for strings, we use double quotes. So that's something to pay attention to as well. But I want to run this one in the debugger and just kind of show you. I'll run it both ways. Let me run it without the debugger first, actually, and show you that it's sitting here waiting. It may not look like it's doing anything right now, but it's waiting for me to push a key on the keyboard. In fact, I can even prove it to you. Let me put a little print statement in here. waiting. So as long as I'm inside of this loop, I'm going to say waiting. And so now here we go. You can see waiting for me to push the key, waiting for me to push the key, waiting for me to push the key, waiting for me to push the key. As soon as I pick a key on the keyboard, boom. What happened? Well, this loop exited. It said what key was pressed, and then it went to check and see. In this case, you can see that since I hit yes, I must have pushed Y, right? That's the key that I must have pressed. But I can run it again and, push a different key, like I pushed L that time. There is no check here for L, just yes or no. So it said, huh? I don't know what that is. Let's take a look at this in a little bit more detail using the debugger. Right? So now, here I am just waiting, and I can sit here and spin all day because I haven't touched any keys yet. So while I have not touched any keys, it sits here inside of this while loop. It's literally waiting for me to push any key on the keyboard. I'm going to push J, and let's see if that's enough to trigger. Oh, see, it's a little tricky with the debugger, isn't it? I don't know actually when I need to push the key to get it to register with the debugger. I can't get it to register my J. Oh, I think I have to hold it down, maybe? No? Alright, well, this example is not working the way I wanted it to at all. So, you're just going to have to take my word for it that it's, I mean, you don't have to take my word for it. I showed you. It was sat there, we call that spinning in this while loop. It sat there spinning in that while loop until I did something, and then the while loop exited. We're actually going to see more spinning with our next example because the mouse works in a very similar way. The big difference with the mouse is that with the mouse we actually care about two motions. I can push the mouse down, and then you can also hold it down, right? So there's also a way to check to see if the mouse button has been released. So if I'm trying to check to see if the mouse button has been clicked, right? Just checking to see if the mouse button has been pressed is not good enough. I need to see if it's been pressed and released. If they push the mouse button down and they hold it down, they might be trying to do something else. They might be trying to do a drag, right? That's a thing we can do as well on our computers. So in order to detect a click, we actually need to check for, two distinct motions. The mouse going down and the mouse going back up. Do I want this one or no, this one's fine. Why is this crossed out? Let me look up. I might be using the wrong thing. Oh, is mouse pressed or what's it called? Mouse pressed. Is mouse pressed is what they want us to use, I think. Right? I actually don't think that is right. I'm a little bit confused. I'm going to leave it the way it was. All right. Let's test this example out. Oh, yeah, I see. No, that is right. Is mouse pressed is correct. I need to change this. I need to write a note to myself to change this so that I don't get confused again. Here, we're asking where the mouse is. What's the X and Y position of the mouse? This only works while you're over the window. So if I pull this window back up, you can see that while my mouse is outside of the window, it says 0, 0. It doesn't know where my mouse is until I hover over the window. And now you can see that it's properly reading the coordinates of where my mouse is. I'm also not clicking the mouse at this point in time. If I just click it, you can see it still says the mouse press is being false. I have to hold the mouse button down, right? So if I'm asking if the mouse is pressed, that means is the button down right now? Is somebody's finger on that button holding it down? So as I hold the mouse button down, you can see it's telling me it is true, but in order to detect the click, I have to let off the mouse button. You see it goes back to false. So the point I was trying to make with that I guess I don't have that example anymore. That's okay. That's okay. Yeah, that's okay. That's good enough for the mouse. Does anybody have any questions about this little mouse demo? The three ones that I showed you are mouse X and mouse Y, which are the X and Y coordinates of where the cursor is. And then there's is mouse press, which is going to be true if somebody's finger is currently holding the mouse button down, and false if somebody's finger is not currently holding the mouse button down. Anybody have any questions about that? All right, then let's talk about animations. So we've shown you how to draw things. So far, all I've drawn are static pictures, which is fine. Pictures are great. Who doesn't like drawing pictures? We're going to ask you to draw flags in class later on this week. It's a really fun studio this week. It's a crowd fan favorite studio. But let's talk about animations. Motion, making things move on the screen, is it takes a little bit more work. So just a little bit of a description about what animation is. We actually trick our brains into think that things are moving by drawing pictures very quickly on the screen, one after the other. This is how movies work. This is how video games work. They're all a series of static pictures that are drawn very quickly, one after the other. And if we do that fast enough, we trick our brains into thinking that those things are moving across the screen. Every one of those pictures is called a frame. So one picture is called a frame, and then I draw another one right after it. And then how fast I draw those frames, that's the frame rate. So any of you gamer nerds out there probably are familiar with the 60 FPS, right? 60 frames per second. That's sort of the gold standard for video game animation and other sorts of animation too. Gives you very smooth motion. 30 frames per second. Still, you'll see the animation, right? It just might look a little choppier because there's longer periods of time in between the frames. So your brain might actually be able to detect that additional longer period of time in between frames. It'll show up as a little bit choppier. But what I want to talk to you about is, the actual process of making the computer draw those frames and doing so very quickly. That's the process of animation, and there's 3 steps. So let's take a look at this moving ball example. I want to run it for you first and show you what it's doing, and then we'll dissect this code. There it goes. The ball is moving across the screen, and once it gets to the right-hand side, it just poof, goes back to the left-hand side and starts the journey. And this is it. This is the whole thing. It doesn't really do much beyond that. But okay, let's take a look and see how it works. There's 3 pieces to any animation that you're going to want to create. The first thing that you're going to want to do actually is to clear the canvas. This gets rid of the last frame. Remember, I'm trying to draw frames very quickly. So I draw the last frame, it's on the screen for a fraction of a second, and then I need to get it out of the way so that I can draw the next frame. So step 1 of the animation process is clear the canvas. Step 2 of the animation process is actually the biggest and most complicated of the steps. That's what this code is doing. Step 2 says, move anything on the canvas that needs to be moved. Some of the stuff might be moving, some of the stuff might be stationary, right? So whatever is moving, whatever is being animated, update its position, change its position somehow, and then redraw everything. You can't just redraw the stuff that is moved. You have to redraw everything, the whole canvas, even the stuff that's not moving. So that's step 2. Clear the canvas, that's step 1. Update the positions of any objects in motion, and then redraw the whole thing. And then step 3, arguably the easiest step, well, actually step 1 is pretty darn easy, is to pause and wait. If we go too fast, it'll be too fast for our eyes to pick it up. The animation won't look realistic. So if I take the pause statement out, you can see that it's choppier. In fact, actually, it was kind of choppy even with, this is a 10 millisecond pause, right? So that means I'm actually getting 100 frames per second in this particular example. That's a lot of frames. But we can switch it, and see this would be 10 frames per second, and you can see that the animation looks a little bit different, arguably smoother, but also slower, because I'm not drawing frames as quickly. So there's kind of an interesting correlation between the two. This is a number that you can definitely guess and check and kind of play around with until you find a good sweet spot that makes the animation look, you know, the way that you think it should look. But just to recap, that looks nice and smooth to me. But anyway, just to recap, the 3 parts of any animation process are clear the canvas, update the position of any objects in motion, and then draw them, and then finally wait. So we show, actually, is this line even necessary? Let me take that out and see. No, that line wasn't even necessary. Really just pausing is the only necessary part for step 3. And then one, of course, final thing to note is that all 3 of those parts are inside of a loop. Every single one of those steps, step 1, 2, and 3, take place inside of a loop. And we haven't seen a loop that looks like this, although I feel like somebody asked me about this either last week or the week before. This is going to run forever. This is an example of a while loop that we are intentionally saying we want to run forever. Why? Because, you know, we can close the program just by clicking the X. So this will literally sit here and move the ball across the screen till the end of time. Yes?
Why do you need to pause?
What?
Happens if you don't pause?
What would happen if you don't pause? It's going to make the animation look, I mean, that's the same as, you know, putting in a pause of 0, right? It's going to make the animation look choppier. You're drawing frames so fast that you're not going to be able to, it's not going to be on the screen long enough for your brain to register the frame properly. So the animation's going to look choppy. Yeah, you first, and I'll come back to you. Yeah.
So what does the show feature do after?
The show feature is used to display everything you've drawn on the canvas. It actually wasn't necessary in this instance. That's why I took it out. But yeah, sometimes show is basically a way to force everything onto the canvas that you've drawn. Yeah. So this pause value is, you know, is one you can kind of play around with. Usually it's going to be between like 10 and 50 milliseconds is a good frame rate for the kinds of stuff we're asking you to do in this class, but it also kind of depends on how good your computer is and how fast it can keep up with the drawing and stuff like that. So a number that works well for my laptop may not be the best number for your laptop. It's going to take a little bit of, you know, trial and error, tweaking to find how long you actually need to pause in between. I, though, would like to take this example up a notch and experiment around with it a little bit. We can see right here the ball goes all the way to the right-hand side of the screen, and then once it gets there, it just magically appears back on the left-hand side of the screen. What if I wanted it to bounce? What if instead of just magically teleporting across the window, I wanted it to bounce? I can do that. That's a thing we can do. Here's the code that's doing the teleporting, right? Saying if the ball is too far right, so the X position of the ball is greater than 1, that means the X position of the center of the ball has gone past the right-hand edge of the screen, because the right-hand edge is at X coordinate of 1. It's saying to set the X position back to 0. Well, if I don't want to change the X position, what I really want to do is I want to change the velocity of the ball, right? And make it go back the other way. So the velocity is actually right here. This is what's known as a magic number, right? It's a number that's just been hard-coded in there, has no description along with it. You know, what the heck does this number do? We need to apply a label to it. I want to actually come up here and make a new variable for the velocity of this ball. Not ball y, ball x velocity. Oh no, 0.005? Was it 2 zeros or 3? I don't remember. I guess we'll find out in a second. And instead of using that hard-coded value down here, I now have this variable. This gets rid of the magic number too. That's a good thing. It's a good thing. So it's still going to do its teleporty thing. I haven't done the bouncing yet. But this also gives us a nice way of changing the speed of the ball. If I take one of these zeros off, right, it should go faster. the velocity should be bigger. It should, whoa, yeah, whoa, that's faster than I was expecting, but yeah. Maybe 0.7. Okay, cool. Or 8, whatever, doesn't matter. All right, now if we want it to bounce, instead of, here I hit the right edge, what do I want it to do? Instead of saying go back to the left, I want to flip the velocity. Some of you might be saying, what if it's not perfectly elastic? And it's not physics class, so we're not going to worry about that here. We're going to keep it simple, and I'm just going to flip the velocity. I'm going to negate it. So it was moving to the right. If I make it negative, that should move it back to the left, right? Let's try it out. Oops. Well, I should assign the variable appropriately, shouldn't I? There's no equal sign on this line. I never assigned it. There we go. Negate it. All right. Now let's see what happens when it gets to the right edge of the screen. Oh, yeah, there we go. It bounced. Now it's going back to the left-hand side, and whoops. Okay. Got to the left-hand side and just kept on going, right? It's going that way. Yeah, what's up? Question? Yeah, I mean, that's kind of our next step, right? Why did it go off to the left-hand side? Because we didn't tell it to do anything differently. We didn't tell it to do anything when it got to the left-hand side. We have one for the right, but we don't have one for the left. So, okay. What do I need here? If ball X is less than 0, too far left. Should I connect these together with an else? Does that matter? What do you think? I think you could. I wouldn't want it to be an else. I would want it to be an else if. But you could connect them together. You don't have to, though. This is also okay to do in this particular situation. In fact, it might be even better to understand that, well, if I go too far left, what am I going to do? I'm actually going to do this, right? So maybe instead of having two if statements, maybe I should combine them together with, what should I do, and or? If the ball is greater than 1, or if the ball X is less than 0, and I'll update this comment. Now I don't need this if statement at all. Done it all in one. That's better, in my opinion. That's cleaner. Let's try it. Let's see if it works. Okay. And yeah, all right, nice. So now it'll sit there and bounce all day. Yeah, question.
This isn't really to do with the code, but how come it flashes when it's on there?
Has everything to do with your frame rate. It's a big combination of stuff. Has to do with how good my computer is at displaying graphics. If you have a graphics card, your computer is going to be faster at doing this stuff than if you don't. It has everything to do with what this number is, right? How long am I pausing between frames? The longer I pause, the more stable it's going to add. If it's flickering, that's often an indication that you want to bump this number up higher, make the frame stay on screen a little bit longer, so that it will hopefully reduce the flickering. But it's still flickering a little bit. Every time it flickers like that, it's really the frame is on the screen for too short of a period for your brain to fully register it. That's what that means. There's a lot of reasons why that can happen, not just one. Yeah, of course. And then the other thing I like to kind of show with this example is, why are we just messing with the X direction? We could very easily do everything in the Y direction as well. So with just a couple of additional variables to represent my Y direction, here's my ball X, my ball Y. Ball y velocity, I'll keep the same, sure, why not? Here I update my ball x position using the velocity. Now I need to have a similar statement for, whoops, didn't mean to delete it. Similar statement for my y velocity. And this is the statement that checks the bounds, you know, for the left and the right. If I run it right now, actually, it'll start to move up and down. Oh, no, it won't. Why not? Oh, why? I see why not. Anybody see why it's still not moving up and down? Yeah.
Does it need to make a SCD draw point that's 0.5 and taller?
Yep. This needs to be the variable that I created. It was hard. That was another magic number. Boo, magic numbers. Don't like magic numbers. Let's try that again. Okay, there we go. The problem here, though, is that I haven't yet put in code to stop me at the top and the bottom. So we need another if statement to check for that. And it'll look very similar to the one we had for x. We're just going to switch everything to the y direction. I might start us a little bit different so we're not just doing corners. And now we have a replication of the DVD symbol bouncing around your screen, right? Will it ever hit the corner? I don't know. We'll have to wait here and see. If you want to take this example even farther, which I think is a fun thing you can do, why stop at just one ball? Could I have 10 balls bouncing around on the screen? Yes. Could I make them bounce off of each other? Yes. Yeah. Absolutely. Yeah, absolutely. So this is a fun little animation example to play around with, and one that's definitely going to come in handy on future homework assignments. Any questions about anything we've covered so far? I have one more, actually slightly different topic to talk to you about for the rest of the day today. But any questions about any ground that we have covered up until this point? So the last topic I want to talk to you about is kind of a different one and also kind of a new one. I'm sure you've probably also already come into contact with it at some point in time. You've probably heard of this thing called ChatGPT. This is the first semester that we have been allowing students to use ChatGPT for this course. Our upper level courses is kind of the same deal. They're all switching to make ChatGPT an allowable resource, which is interesting. It's a very interesting time that we live in. ChatGPT is very good at cranking out certain pieces of code for us. And I want to show you a little bit about that today. How somebody in your position can use ChatGPT to help you learn. Because a lot of what I've seen in the past is people using ChatGPT just to get the homework done, but that's not, the goal is to learn. The goal is to understand. So how can we use ChatGPT not just to give me good code, but to actually help me understand what's going on? And with that, I want to kind of talk about the next homework assignment. I want to introduce, this is a brand new one this semester. We're asking you to create a very watered down version of Cookie Clicker, which I love Cookie Clicker. I've played the crap out of it. I love games like Cookie Clicker, idle games, incremental games, big fan, play them all the time. So this is a very, 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 very simple version. If you haven't played Cookie Clicker, I mean, well, maybe you shouldn't, because it'll eat your life and you have other things that are more important to do probably. But, it's a great game. What do? There's a cookie on the screen and you click on it. It's called Cookie Clicker. Every time you click the cookie, you get a cookie. So there's a counter on the screen, right? I suppose I could just show you the actual Cookie Clicker, right? So I start with 0 cookies, and then when I click it, it gives me a cookie. And as I click the cookie, it gives me more cookies. After a while, you're probably getting tired of clicking, so they give you a way to automatically earn cookies. So now you see it's this number will go up on its own, right? I don't have to click anymore. It'll just go up automatically. There's a whole lot of other things that this game can do, but for the assignment, that's basically what we're asking you to do. There's a little bit more to it than that. Everything that this is a brand new assignment that we have not actually tried this one out yet this year. So you all get to be our guinea pigs / lucky cookie clicker creators. And the fun thing about it is you certainly could do all of this without using ChatGPT. I did that very thing when we were developing this assignment. It's doable without ChatGPT. I've shown you everything you need in class with the Standard Draw API. You might have to look up a couple things on your own with the API, but nothing too crazy. You can do this all yourself. But some of the things that we're asking you to do are kind of tricky. Some of them involve actually a bit of math, a bit of geometry, which while you certainly could do, would be perhaps a little bit tedious, not the most fun part of the assignment to do. We're actually encouraging you to use ChatGPT to help you out on this assignment. We're actually hoping that you will use ChatGPT to help you out. That doesn't mean that ChatGPT is going to do it all for you, though, right? That's why we're having this conversation. If you copy paste everything into ChatGPT and it spits out the code, that doesn't mean you just get to call it a day and this assignment's over. You still are going to have to demo that code, and you're still going to be asked questions about it. So even if the code that ChatGPT gives you works, you're still responsible for understanding it. And that's important. It's important to understand what ChatGPT is telling you, what the code is that you're looking at, so that you're not just blindly using everything. And there's a lot of good reasons for that. ChatGPT can be wrong. ChatGPT is not always correct. That might seem like a silly thing to say, but it's already popped up and had some very serious ramifications in certain areas. There were lawyers who were using ChatGPT to help them study case law, and ChatGPT was making up case law that did not exist and telling these lawyers that these cases exist that they could use, but they weren't real, right? So ChatGPT makes mistakes. It does things that might seem strange. ChatGPT also, one of the interesting things about it, and one of the things that makes it useful, believe it or not, if you ask it the same question twice in a row, you may not get the same answer back. So we say it's non-deterministic. There's a degree of randomness in there to understand why that's valuable, why that's the case. Think about, the same thing's true for a human, right? If I walk up to somebody and I say, hey, how's it going? And then I see them 5-10 minutes later even, and I say, hey, how's it going? I'm not necessarily going to get the same answer back. Maybe I will, maybe I won't, right? Depends on kind of what happened. So how can you use ChatGPT to help you, not just on this assignment, but in general with computer coding kinds of things? Having ChatGPT solve big problems all at once, bad idea. You want to use ChatGPT to help you solve problems just in the same way that you would. Break the problem down into smaller chunks and use ChatGPT to help you solve those smaller chunks, making sure that you understand what's going on every step of the way. And so I'm actually going to start the next homework assignment right now using ChatGPT with you, give you the first step or two of the homework assignment. The very first thing that it asks you to do is to draw a cookie. So we need to draw a cookie in the middle of the screen. And I know some of you, this might sound fun to some of you, right? There's a lot of artistically inclined people in this room, I bet. Others of you might be like, wow, that sounds like a really boring chore to have to do. Why should I have to figure out how to draw a cookie? We want it to be a chocolate chip cookie. It wants to have a random amount of chocolate chips distributed around. So that adds a whole other hurdle to it, right? Okay. Well, let's see what ChatGPT has to say about it. When you're using ChatGPT, keep in mind, ChatGPT is very smart. ChatGPT knows coding concepts that you haven't even seen yet before. So if it gives you back something that looks confusing to you, you might have to tell it to take a couple steps back and make it, take some of the more advanced stuff out and make it easier for you to understand. It also knows about Standard Draw. So it's smart enough to use Standard Draw. In fact, I think that's an important piece of context for you to keep in mind as you're using ChatGPT. So, if I want to, I might say use Standard Draw to draw a chocolate chip cookie. Boom. All right. Here's the chocolate chip cookie that it's come up with. You can see it's even commented the chips for me. That's great. Let's see if it works. Let's see what it looks like. I'm going to take this code and I'm going to copy it into, I actually have the assignment 4 repository up. It's blank. There's nothing in it. There's no starter code. But let's go ahead and paste it in and see what ChatGPT is giving for us. Oh, beautiful. It's a chocolate chip cookie if I've ever seen one. But wait, that's not what we asked for. We wanted a random number of chips, and we wanted them to be randomly placed as well. And we can see that that's actually not what ChatGPT gave us. We didn't tell it that yet, right? We can see that these are all magic numbers. They're hard-coded in there. And there's always going to be 5, right? So, you know, maybe we want to say use a random number of chips. All right, and so, wow. It modified the last example and added in some code to do a random number of chips. However, notice it didn't do random things like we've talked about how to do random things. Will this code work? I mean, you can always plug it in and try it, right? If you want to see if it's going to work or not, that's definitely a thing you can do and should do. Absolutely. But the other thing to remember is that we want you to be able to understand this. Whoops, did I not copy it properly? Oh, I need to, it's doing random numbers differently, so I have to take that into account. You have to be able to understand what's going on. Oh, that's, okay. I don't know if I'd eat that one. Oh, that one's off the, that's okay, that's okay. Okay, yeah, they're kind of going off the edge. Could you fix that? Could you go through this code and fix that? I mean, that's an interesting question. But another interesting, get back to what I was talking about. We don't generate random numbers this way. That's not what we do. So, you know, if you want to, you can say use math.random instead. And it will redo the whole thing. This time, instead of doing that business we saw before, oh, hey, we've seen statements that look like this, right? That was on the last exam that you just took last week. You know, so you can have ChatGPT work within the confines of stuff that you know. That is definitely a good thing to do. If you see it's doing random numbers differently, tell them to do it the way that you know. Tell them to do it the way that you know how to do it. If you see that it's, so this example doesn't show that, doesn't show, but maybe I can use standard draw to draw a, let's see if I can get it to make me another one that does something a little more advanced. I was trying to get it to give me a different answer, but it wasn't going to. Sometimes it'll give you stuff that is not all inside of main. And that means that it's using actually what we're going to be talking about next week, methods, right? Some of you maybe have been introduced to those already, but if you haven't been, then something that would be very useful to tell ChatGPT would be put all the code into main, right? Put it all into main. If you see that it's got code spread out all over the where and yet all over the place and you don't understand how it works, tell it to put all the code in main, and it will. It will. So yes, we want you to use ChatGPT in this way, but we also want you to look at the results and understand it. You're still going to be asked at the demo questions about this code to judge your understanding of it, right? So if you let ChatGPT use all of its advanced concepts, you're going to have a bad time when you try and go turn that code in, even if it does everything we told you to do. So just kind of keep that in mind when using ChatGPT. You know, can you just take the entire assignment and dump the whole thing in there? Yeah, but I don't think you're going to learn that way. I don't think you're going to understand the code that you get that way. There are other things that maybe you don't feel like you need ChatGPT for. I can tell you right now, there are some parts of this that I'd probably rather do myself, you know, like the power-ups and stuff. I don't know that I need ChatGPT for that, but for detecting when the user clicks on a cookie, oh, I would be using ChatGPT for that one for sure. That one sounds kind of like a pain in the butt. So you know, instead of using ChatGPT for all of this in one whack, we're encouraging you to use ChatGPT for one of these at a time. That's kind of the point I'm trying to make. ChatGPT is a good tool, but like all tools, they can be used the wrong way. I can use a hammer to put nails into the wall, but I can also smack myself in the thumb, right? Any tool can be used in a harmful way if you're not careful. Yes? Yeah, somebody asked me about that on Piazza just earlier today. That's a mistake. If you got the Cookie Clicker repository before I fixed it, which was like an hour or two before class, it's, I don't, okay, I guess I have to go fix it again because I'm confused now because I swore I fixed it this morning. So that makes me a little annoyed, but that's not your fault. That's a me thing. If you have the old version, just delete all of it, honestly, and make it, there's no starter code for this assignment, none, blank. So if you see stuff in the repository about zombies, you can ignore it, you can delete it, and just make a brand new Cookie Clicker file, whatever you need to do. Sorry about that, and thanks for letting me know again. I'll eventually get it right. Okay, I think that's it for now. Let me know if you have any questions. Otherwise, I'll see you in class for Flag Day later this week. Have a good week, everyone.